everyone, welcome to my channel. Can you solve the integrals from CET exam pattern? The answer is yes, of course. We can crack the CUT exam if you know certain tricks apart from standard formulas and properties of integrals. Let's have a look into the question. The question has been asked from the year CUT 2023. Integral of 1 plus x square over 1 plus x square times e to the power of tan inverse of x dx is equal to. The options are given as x equals e power tan inverse of x plus c. Second option is e power tan inverse of x minus x plus c. Third option is e power tan inverse of x plus c. Fourth option is x e power tan inverse of x plus c. Whenever the question appears with e raised to the power of something, it's better to think about this trick or rule, which is e power x f of x plus f dash of x and then dx, which is equal to e power x f of x plus c. This is the trick we need to apply. Most of the time the questions from CUT is based on this trick only. So whenever e raised to the power of some function appears before us, try to recall this trick. Okay, let's see what it says. The trick says you are having the exponential function with you raised to the power of some function. Along with that, one function appears plus the second term happens to be the derivative of the first function. Like this, the question is asked. The integral or the integrand is so simple. You need to write the exponential function as it is along with the function what they have provided in the question plus c. This is the way of giving the answer. Now, we'll try to compare the question with this pattern. If you look at the question, we have got e to the power of x. Yes, but if you look inside the bracket, actually they have given us algebraic function, but it looks so clumsy. We are not having two terms separately like that. 1 plus x square has been given over 1 plus x square has been given. A fraction kind of question has been given. It's not matching exactly with the pattern. So what we are going to do means we are going to make some rearrangements here. So whenever the question is so complicated, we will be always thinking about substitution technique. So here also we'll think about substitution technique. So what to assume or what to substitute for our t. So whenever a fraction as well as e raised to the power of something has been given to you, you need to give priority to your power. Because power only happens to be complicated most of the time, that too here inverse trigonometric function has been given. Suppose if it's simply a fraction, you can think about substituting the denominator as your t and you can proceed for substitution technique. But both the things has been given to you. So give priority to the power first. Power is an inverse trigonometric function. So better we'll assume that as our t. So put e is equal to tan inverse of x. We know how to differentiate our tan inverse of x. That is nothing but 1 over 1 plus x square. We are going to find the derivative of t with respect to x. So I am writing here dx. Now what we are going to do means we are going to rewrite our given question. So that will become, here if you observe in the question, 1 plus x square is there in the bottom along the dx. So that has to be written as dt and this should be written as e power t. So like that we are going to write 1 plus x square will be remaining as it is. There we need to substitute in terms of t. For that we are going to rewrite our tan inverse of x as x equals, this tan inverse if it moves on the other side, it becomes our trigonometric tan t. So this we can use for our 1 plus x square. Now we'll substitute everything. So that becomes 1 plus x square. Along with that e power t dt. Yes, this has to be replaced with our tan t. That only we are going to do now. So 1 plus tan square t plus tan t, and then we have got e power t dt. 1 plus tan square is nothing but our secant square. We know our Pythagoreanity. So this can be written as secant square t plus tan t e power t dt, along with that our integral symbol. Now, if you observe what we have learned earlier in the formula, exponential should be there raised to the power of some function. Along with that, one function they will provide. If you look into tan t is our normal function, derivative of our tan t is nothing but secant square t. We know the derivative formula already. So, the values whatever we have got so far, that is exactly matching with the trick what we have learned earlier. Here if you look into e power x is our e power t, f of x happens to be tan t, and f dash of x happens to be our secant square t. So it's matching exactly with the trick. So what we have to do, no need to waste time. We need to give the answer as e power x times f of x plus c. So that only we are going to do. So e power t times tan t. That we are going to write now. So e power t tan t plus c. Actually, if you look into our options, that has been given in terms of x. So we are going to convert everything in terms of x. T is actually what we have assumed that to be tan inverse of x. That only we are going to write down now. So e power tan inverse of x times tan inverse of x. Actually, if you look into tan inverse are opposite functions, so we can cancel them nicely. So we have got simply x. So x times e power tan inverse of x plus c. They are inverse to each other. That's why they have cancelled it. And this is our final answer. So if we look for the option, this is exactly matching with the fourth option. This is our actual answer. Thanks for watching. Happy mathing.